Now we're going to look at intersects. Now intersects on equations, well, let's do a little investigation to see what that might look like. So we've got two lines here, one is 2x plus 1 and one is y equals 4 minus x. So let's draw them and have a little go at this. So for this first line here, we know that well, the y-intercept is going to be positive 1, it says it here, and using rise over run, so rise over run, we know that its slope or its gradient is going to be 2 over 1. So let's look at the run. The run is 1. So from this point that we know, I'm going to go across 1 here, and our rise is 2. So I'm going to go 1, 2, up to here. Across 1, up 2. Now with those lines here, so let's just dot that out. Yeah, so we've got 2, we have 1. Now let's draw this line. Oh, so we've drawn the first line, now let's get the second one. Oh, we have y equals 4 minus x. Well, I know that the number multiplied by x is the slope, so I might rewrite this in y equals mx plus c, just in that form to make it a little less confusing for myself. So I have y equals, well, mx, the number multiplied by x. Well, that's going to be the negative x here, remember? There's nothing there, it means it's just multiplied by 1. So I'm putting the 1 there just to help me out later. And then our y-intercept is going to be at 4, positive 4. So we have our slope is negative 1x and 4. So we know our line's going to be negative as it goes from left to right, so it's going to be going down this way. So let's plot it. Let's start at 4, the point we know. And we know using rise over run, I'm going to write that as a fraction here. I've got our run is 1, so as I go 1 across, I'm going to go down 1. Oh, that's right here. As I go 1 across, I'm going to go down 1, 1 across, down 1. Now I have enough to draw my line. I'm going to line them all up here. So bang. There we go. So here's my line here. Y equals negative x plus 4. And this one is y equals 2x plus 1. Now when I'm talking about my intersect, I'm talking about where on both of these lines the x and the y coordinates are the same, and that is where they cross over, and it is what we call the intersect. So if you look where these two lines meet, you see it happens right here where they cross over. Now if I was asked to find the intersect of a line, I would need to draw the lines and then find the coordinates in which they crossed over where their x and y values were both the same. So I know from graphing this here that the intersect of these two lines is going to be x as 1 and our y value, so x1, and our y is going to be 1, 2, 3. So our intersect is 1 and 3. So intersecting lines occur, or the intersect of two equations is where the lines meet and cross over. Now let's have a look at another little interesting point here. Say I have these two lines, y equals 2x minus 2. Well, let's draw this really quick. Well, minus 2, we know it's going to start there, rise over run. If I rewrite that as a fraction, it's going to be 2 over 1. So my run is 1, go across 1, my rise is 2, 1, 2. Here's my point, there's my next point. Let's draw this up really quick. Line that up there. There's my line. Now let's look at this one. 2x plus 2. So we know to start at plus 2. Using my rise over run, I know my slope or gradient is going to be 2 over 1. So my run is going to be 1, and up 2, 1, up 2. I have enough to draw this line now. So let's line those up here. Now, the thing you'll notice about these lines here is you're not going to have an intersect. They're never actually going to meet. And this is what we call parallel lines. Parallel lines, sorry. So, one thing you'll notice is the gradient for each is the same. So, if the gradients are the same, the lines will be parallel. So, for lines to be intersecting, they must have different gradients. To have an intersect of two equations, the gradients must be different. If it's the same, your lines are going to be parallel and they're never going to meet.